My name is Brandon Leach. I am a SQL Server infrastructure architect for a hedge fund. I'm not allowed to technically say which one, but I'm sure you can figure it out with a little bit of research. Now, if you want to reach me, there's several ways to do so. You can find me on LinkedIn. You can find me on Twitter. You can even hunt me down on Facebook. Or you can just email me at brandon@sqlservernerd.com. Years ago, I worked for a company called SurveyMonkey, and they made me go through this whole exercise of branding. Well, anyways, I've been working with SQL Server for over 15 years. I've worked in some crazy environments. For example, a previous company of mine had 20,000 databases spread across 1,800 instances of SQL Server, totaling about 6 petabytes of data, and they created 200 databases per week. You don't have an environment like that without running into problems. So, unfortunately, I have learned a lot about corruption. Unfortunately, I learned that for the first time at 3 in the morning. Anyone else?
That's usually how it happens.
Unfortunately, yes. Which is why I put this section together, is so that hopefully those of you who have not experienced corruption will have an idea of what to do and what not to do. I really don't want you to have to go through that pain, because we make mistakes, right? We Google things on the internet that turn out to be bad information. And let me tell you, there is a lot of bad information around corruption out on the internet. So, with that in mind, we're first going to discuss what corruption actually is. We're going to talk about how we can monitor for it using out-of-the-box tooling. And then we'll move into things regarding how we can respond, right? What is our role in that process? I am not going to pull out a hex editor today, right? If that's what you're expecting, you're in the wrong session. This is, as I said, it's for the beginners. This is practical process and knowledge. At the end of this session, you're going to really look at your backup strategy. You're going to maybe set things up a little differently. Now, I'm also going to give you some quick, easy scripts for those of you who may not have anything in place today. All of it is out of the box. You don't need to buy anything. It's just what's available in SQL Server. Now, the other thing I'll mention is that these slides are a bit of wall of text, and there's a reason for that. I wanted this deck to be something that you could refer back to at 3 in the morning when you get that call, right? Something to provide you with a list of good information so that you don't do things like run repair allow data loss. So let's define database corruption. So basically, for this session, we're going to talk about database corruption in terms of corruption within the data or log files of SQL Server, right, of a database. We're not going to talk about what happens when you get bad data, right? That's a whole different talk. So we're focused on the physical structure of the file. To that end, there is a certain mindset that goes along with DR. So who here has seen corruption before? Please raise your... Oh, a good number of you. Would you say that you were successful in your first attempt at recovery? Okay, I see Sandra there. I see some people not so sure. Well, we have to understand that disaster is going to happen, right? This could be due to corruption. It could be due to a data center outage, a cloud region outage. And we need to plan for these things. We need to have tested policies in place. We want to make sure that we're as well prepared for when it happens as we can be. We also need to learn from it. Anyone want to take a guess where in here database corruption can occur? Now, keep in mind, on the left side, on this side right here, we have your standard setup where your instance is connected to a SAN, and that's where the data lives. On the right, direct attached. Anyone want to take a guess where corruption can or will occur there? Correct. Oftentimes, corruption will be introduced due to an issue with your storage. And sometimes you won't even know, right? It won't show up immediately. It will live there for a long time. And those errors from the hardware can build up until at some point you've lost your data. It can happen due to an issue with firmware in the RAID controller, or it could be a switch issue that causes it. The more complex our environment, the more likely it is to happen. Now, SQL Server provides three main tools for monitoring for corruption. The first is SQL Agent Alerts. Anyone actually use alerts in SQL Agent today? A few of you. I'm actually shocked. Usually nobody raises their hand. So, everyone knows what CheckDB is, I hope, right? And can everyone here say that they run CheckDB at least once a week? I did not see as many hands as I wanted to. I mean, really, you should be running CheckDB as often as you can. And we'll also get into a bit of a quick discussion on where you should run CheckDB and when. This last one, does anyone use this? Okay, there's like 5 hands that went up. That's not unexpected. We're going to talk quickly about each of these. Oh, sorry, it went way in advance on me. This laptop is a little sensitive. So let's talk about SQL Agent Alerts for those of you not using them. So these allow us to create alerts for when specific errors are triggered, or when an error of a specific severity level is triggered. Now, the higher the severity number, the worse off we are, generally, right? The more critical it is. For example, a severity of 25, yeah, you've got a pretty good chance of having corruption at that point. You're probably having hardware failure. But none of this is set up out of the box. You have to create these alerts yourself, and we'll go there in a. We'll go there in a bit. So let's talk about suspect pages before moving on to DBCC. There's an interesting thing that happens. Whenever SQL Server suspects that a page might be corrupt, it makes a note of it. And that note is in MSDB, in the suspect pages table. Now, it doesn't clean this out automatically, but you could put monitoring on this, and it would tell you if trigger an alert through PagerDuty or whatever your notification system is, when a new entry is put in that table. Because then you can go and you can validate that it either is or is not corruption, but then you have to clean out the table yourself. So, let's, why is this jumping? Thank you. All right. Now, I said I was going to make things easy on you. And so, what I've done here is I've scripted out a bunch of alerts with various severities. And I have also scripted out an extra one, this error 825. Now, what error 825 in SQL Server is a memory-related error. It had to try twice to read a page from memory. This could be potentially failing memory, but it might not be. So if you see this, then what you would want to do is you'd want to go to your infrastructure team and have them do checks on the memory. Make sure everything's in good health. Maybe they come back to you and they say, yeah, all looks good. Maybe they come back to you and they say, yeah, we've got a problem. We're going to replace that memory module tomorrow. Right? But literally, all you need to do is execute this script, and it'll create all of these alerts, and there's quite a few. Everything from 17 up, plus that 825 error. Now, as I mentioned briefly before, we really want to start paying attention around severity 19 and up. That's the stuff that's typically going to lead us to corruption. And as we get further in that severity, some of these mean we do have corruption. The integrity of a table is in question, right? Or the integrity of the database is in question. So, just run this. You'll get everything you need on an instance. If you have no other options, no other tooling, good. This will take care of you and help you. Now, if I go back, let's talk about CheckDB. So, as we know, this is the tool that everyone uses to truly validate the integrity of your database. If I saw something in suspect pages, or I got an alert from agent, my next step would probably be to come here. How many of you have calculated maintenance into your system builds for your instances? What do you usually use? Is it like 30%, 20%? So my question is, what do people typically reserve in terms of resources, CPU, memory, for maintenance?
We run it on a snapshot, on a separate VM.
So you're not really reserving anything. So we'll get to why that isn't an actual one-to-one comparison there. Yes?
There's a question from online people. Do you have any recommendations for running CheckDB on very large single-file databases where CheckDB can't finish within your maintenance window? run it against the replica if we have one, but it seems slow to me or separate.
So to repeat the question is any recommendations for running CheckDB on large databases where you may not be able to run it all at once? And yes, there are. CheckDB is actually a set of commands that it executes. And you can run those commands on specific tables. You don't have to do it all at once. You can access and use the subcommands yourself. So you could say, I'm going to check the integrity of these tables today, those tables tomorrow, and you can spread that out. Now, if you've got a 100 terabyte table, it's still going to take a while to do that table. But for most people, should be able to find a nice, easy way to split out the work. So I hope that answers the question. Do we have any others before I go on? All right. So if you're not running CheckDB weekly, you need to start, right? The other thing to note is here's where people screw up a lot. They freak out. They end up running repair allow data loss. And the problem with repair allow data loss is it tries to do whatever it can with no restrictions to bring that database back into a safe, consistent state. First part of that, the focus is on bringing the database back into a safe, consistent state. It doesn't care about your data. That's why it says data loss. It will cut out whatever it has to and just toss it in the garbage without a second thought. No confirmation, no logging of what it got rid of, nothing. This is very common for people, a very common mistake for people to make, unfortunately. And it doesn't end well. I once saw advice where someone suggested running repair allow data loss on MSDB. Let me tell you, it's actually possible to have a job step disappear from a job because someone ran repair allow data loss. Yet the job still runs without error. I think we can all see why that's not a great idea, right? Please do not do this. The only time you should ever run repair allow data loss is when Microsoft says, yeah, run it. And I'll tell you, I have actually run it at their direction without actually losing data. There are certain scenarios, such as corruption in page free space pages, where you may need to do that. Typical process if you want to recover from that, and a restore is going to take too long. Add it, if you get a PFS page corrupt, add a new file, empty the data file with the corruption, and then call Microsoft, because they will see what's going on and they'll go, yeah, run repair allow data loss, because it'll only affect that file at that time. Do not do it on your own. Make the call. You pay Microsoft, right? Might as well take advantage of that support and make sure that when all is said and done, you are still supported. Running repair allow data loss, they will not help you after that. Not unless they have told you to do it. So cover yourself. Cover your company. Make sure that you are within the bounds of the SLA you agreed to with them. Now, before we go into a demo of CheckDB, and a very simple type of corruption. I want to talk about restores for a minute because there's a lot of bad information out there. How many people take backups? There are like 98% of hands went up. Okay, so here's the thing. If you're not taking backups, you need to take backups. How many of you, though, restore your backups? Like actually fully restore them to a DR system? Far fewer hands. That's what I expected. So what happens if you restore your backup and it doesn't restore? Or corruption is still in the backup because it's been there for weeks or months and no one noticed, right? I occasionally get phone calls from random people going, "Hi, so-and-so gave me your number. My database is corrupt and the backups are no good." Well, that's the worst possible situation you can be in, right? You're either going to do one of two things. You're going to pay millions of dollars to some other company to try to recover your data. B, you're going to be very lucky and you're going to have kind of a log ship copy from a long time ago prior to the corruption to recover from. Or C, you're going to have to lose that data and cut it out, right? That could be life or death for a company, that last scenario. When we don't have proper backups, that's an RGE, a resume generating event. I borrowed that term from Paul Randall, who's the first person who said that I heard. So the other thing is, how many of you have had your VMware guys or your virtualization team come to you and say, "Oh, don't worry about backups. We take care of that for you"? Yep. They lie. The problem is they do snapshots. And here's the thing. If you've ever tried to restore a SQL Server database from a snapshot, 9 times out of 10, it comes up in suspect mode. And it comes up in suspect mode because you have this thing where they've snapshotted one volume at one time and another volume with your logs at a different time. Database is inconsistent. You now have data loss, right? You're going to have to go into what's called emergency mode to look at that data. You're going to have to tell SQL Server to toss out the log file and build a new one. Yep. Sorry, someone's pointing this way? Yes, sorry.
SAN snapshots are many times SQL aware, so they freeze the whole database at the same time.
Ideally, yes. Ideally, yes. But that depends on your SAN admins being smart enough to configure it the right way, right? Here's the problem. You or they are not the ones who are going to get fired when that restore goes bad. Yet they're the ones managing it. What's going to happen is they're going to blame the DBA. DBA is default blame acceptor, right? We know this. It's always the database's fault. So if we're relying on an external team, even if it is SAN aware, even if it uses a VDI interface and it, freezes everything, well, not all environments are able to handle that break in latency either. For example, I work for a hedge fund. We trade in the last 5 minutes of market close and the first 5 minutes of market open. And we absolutely have to be first at that time. and we're in every market in the world. If there's a stock market, we are in it. So to pause I/O for a few minutes or a few seconds, we can't do that. We're doing hundreds of thousands of transactions per second, totaling billions. We're an edge case. But if that I/O freeze happens at the wrong moment, it can hurt not just us, but many other companies. So it's something you have to understand your tolerance for, right? It's a use case thing. But the bigger issue is trust. Do you trust your SAN admins with taking backups of SQL Server? I generally don't. It's not their forte. They wouldn't trust me necessarily to configure their SANs, right? I guarantee you they know 10 times more about SANs than I do. I know a good amount because I've been working with them for years, but they're the experts, not me. They're the ones at the end of the day who are responsible for that SAN. I'm the one who's responsible for the SQL Server backups. So, another common misconception. Clusters and availability groups are not a replacement for backups, right? A lot of people think, oh, you know, if you've got an availability group and there's corruption, the page will just come across from one of the secondaries. And let me tell you, while it is painful to intentionally corrupt a database in an availability group, specifically on the secondary to test, it's doable. And that corruption can go from one replica to the next. It can travel across. So, availability groups provide that nice little extra tool, but it's a trust but verify thing, right? And it's not a replacement for backups. And if you're using failover cluster instances, well, you've got shared storage, so there is no second copy of the database. All right, we need to talk about incident management for a little bit, and then we're going to dig in and we're going to look at some corruption. So I hope you're all familiar with whatever policies your company has for incident management. But this is the reason I have this in here is there are a lot of people that in the heat of the moment, they make a mistake. They don't play their role. So good elements of incident management are having a leader, typically an incident commander or incident manager on call, someone whose role it is to get the right people in the room so that this can be investigated and resolved. Now, obviously, we should have good policies and procedures documented. This is a failing in a lot of companies. A lot of companies don't document things as they should. We don't document things as we should. There's another piece. Anyone here not know what a postmortem is? Okay. So you're all aware that it's a way of just describing what happened, why it happened, what can we do to prevent it. I literally worked for a company at one point where we had this guy who every quarter he would go over all the postmortems that were still open, still had action items. And if those action items hadn't been taken care of, you got one warning. If the next quarter those action items weren't taken care of, you were walked out the door. The guy had no qualms about firing anyone. He just, if you did not follow up, you were walked out the door. We never had the same issue twice while I was there. Because people did what they were supposed to. They documented what happened, they figured out what they could do to make the environment more resilient, and they made those changes. And if they were blocked for any reason, he unblocked you. You need X to do this? No argument, here you go. So, a few quick things. Step one, when corruption happens. Take a deep breath, give yourself a minute or two to compose yourself, relax. And then, let's talk about our role. So, we would inform the stakeholders. Usually all we should have to do is inform that incident manager on call. This should be documented in our protocols. We get the right people in the room. And this next part is key. We don't touch anything. We remain calm. We wait for the right people to come in. And then we start discussing. If we just start taking action, we can make the situation worse. And then we will have an RGE. Right? Think about this. Every system has an owner. Every database has an owner. Right? Is it us? Not often. If we just take action and it's the wrong action, that's on us. The company will let you go, and they'd be right to do so. However, if we can't convince the stakeholder of what we know to be the right path, is it the right path? No, it may not be. It's our job to inform them and to let them make the decision. If the stakeholder makes a decision and it's to allow some data loss, then they take ownership of that, right? As owner of the system. If we just do it, then we are at fault and we have caused data loss. We will no longer be employed. So let's talk about assessing the situation, right? Once we've got the right people in the room, we can start gathering information. We might go to we might run CheckDB and see what the output is, right? Or maybe that was already gathered because that's how we got alerted. Some things you might want to check on. Is a restore the only option? Depending upon the type of corruption, that could often be the case. Sometimes there are other ways, though. Is it isolated to a single node, and is that part of a failover cluster or availability group? We need to know that. For example, if we have to restore this database, well, we're going to have to reseed all the other availability group records. So things we're going to look at. We're going to look at the CheckDB output. We're going to look at system event logs, including the SQL Server error log. And we're going to try to understand the timeline of what happened. We'll probably also bring in other teams as needed to do assessment on their side. So we're going to work this issue as a group, and let's go to here. Let's actually look at a couple different types of corruption. Now, one of these, I actually don't know what's corrupt. I had a coworker of mine corrupt the database. We're going to take a look at it. I can't tell you if it's recoverable or not. It's going to be fun. So, if I go down here a little bit and further into this script, we're going to look at the first one, which I do know. And there's a lot of extra things in here for you to kind of explore with. So, here's how I like to run CheckDB. I use the all error messages option. I use the no info messages. The difference between that is no info messages ensures you don't get the chaff, right? The noise. All error messages make sure that you get all actual errors that it found. And the last one is undocumented, but should be pretty self-explanatory. It formats the results instead of being text into a table. Right? Now you can take that, it's a little easier to read, or you could store it for future. So, I need to change my database context here to a corruption demo. And let's run this. Yeah, so if I copy one of these out, or rather, I'll just show this. We can see that there's an error in a table, right? And it goes way down. It gives us the allocation unit, the whole 9 yards. Anyone notice anything interesting about this corruption? Yep. Bingo. So that one, anyone want to guess what we do in that situation? Drop the index and rebuild. Yep. But we can tell that just from this output that there is a much easier way to deal with this corruption. So, let me get out of Zoom it here. Now, I already know which index this is. So, what we're going to do is we're going to execute these two statements. We're going to disable the index first. That means queries won't use it. Some plans will probably recompile. And then we're going to rebuild. So I hit F5 here, and we're done. Now if I go back up here to our, there it is. Now I hit F5 again. That's nice. Easy. I'll give you another easy one. What happens if tempdb goes corrupt? That won't always get rid of it, though. I know, at least in some versions of SQL Server, you actually have to delete the tempdb files. It's possible for them to get reused, and the corruption is still in there. But, in general, yes, restart the instance. And I'm sorry I couldn't see you before. The light was right in my eyes above you. All right, so let's actually go and we're going to take this CheckDB and we're going to go look at another case here. This is the unknown case. So I'm going to do a new query. I'm going to set my database context to unknown corruption. And let's see what we get. Oh. Did TG not send me the thing? Okay. Give me 1 second here, and I will give you another type of corruption. I just need to do this a little bit off screen. Because I am not teaching you how to corrupt. Yeah. I have actually built tools for this. Yeah, I know, that's terrifying, isn't it? Let's see. Okay, it's a different file. One moment. And we will go and where is the corrupt my database file? There it is. The what? The DRG? No, that is, let's see. Okay, I'm going to corrupt this nicely. We're going to talk about IAM page corruption. IAM page corruption. That's how SQL Server keeps track of what objects are allocated or what extents are allocated to an object. I just need to find the page. So if I go back here, where is my DBCC IND? Should be in here. Okay. Unknown, need to change this to unknown corruption, because that's the database name. And I'll be done and back on in one moment. Because I need to change the context. Okay. What is that table name? Okay, so, sorry, this is taking a little longer than what I would have liked. That's why. The table does not exist. So let me create that table. Or let me create a table for this. So this part here is, we're going to insert 5,000 rows so that I can then corrupt the table. And there we go. Now I can use that undocumented command, and page ID is 463. That was the last piece I needed. So I'm going to change this to 463. And then, there we go. And if I plug in again, there it is. Oh, wait, let me get off that page first. Sorry. Undocumented commands that should not be learned. Let's do things the right way. All right, so that should come back up in a moment. There we go. So let's go check DBCC. And we're in the unknown corruption. Oh, still not corrupt. All right, well, all this will take is 2 seconds, and I will guarantee it's corrupt. Because I have all of this scripted out. So, oh, I see what happened.
I think you need to change the
Yeah, well, pretend you didn't see that. Here. I mean, at this point, it's out of the bag, so. There's this horrible command, do not ever run this. Yeah, if you have to, you've done something horribly wrong. Yeah, you can. You absolutely can. But you should never, ever have to. So file ID, page ID, offset, let's just do 60. Right?
You want to change to non-corruption, huh?
We're going to corrupt. So. Now, let's check DB again. And,
It's different data.
You corrupted the wrong database.
no. Oh.
The corruption demo.
No, it's unknown corruption database.
But
Oh, you're right. You're right. Time zones, right? Thank you. My apologies. I'll just have another database to fix after this. Which is fine because it's meant to be corrupt anyways. Thank you. See, this is why we work in groups. I've got 5 minutes. Okay, so that's going to take a little bit longer, but it did its thing. So now, if I go over here and I run CheckDB, it hates me today. This was working an hour ago. No, actually. No, it is corrupt. I guarantee you that. Why do I guarantee you that? Because literally what this does is it overwrites bits in the page.
Yes, but the DBCC does not. Thank you. So how do you know it's corrupted? The DBCC doesn't show you anything.
You don't, and that's the problem. In a normal situation, you don't. But we know that I have specifically run this command and introduced corruption.
If you select from it, will
Do you know what table it is? Can you select from the table?
We can try.
if you got the page ID wrong, then you could be corrupting a page that isn't actually being.
Yeah.
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 I mean, let's look at DBCC IND again, right? What we're specifically looking for here, there we go, 463. So you're exactly right. So if I change this, and I do that, we should finally see it. Yeah? Yeah, I missed that, thank you. There we go. There we go. All right, now I'll go back here, and we should finally see it. And we do. We absolutely do. Now, if we look quickly through this, because I've got like 2 minutes left, so I appreciate you bearing with me, we see a whole bunch of errors. Right? We see information that there's an issue with some of the system. You can see that. Extent is marked allocated in the GAM, but no SGAM or IAM page has allocated it. Right? We see a table error here. We see the index allocation map is pointed to by the next pointer of IAM page in object, and then it goes on for there. That's giving us a clear indication that we have a problem with our index allocation map page. So, if I expand here, right, the information goes on. So, what do you think we should do? You might look at the page, yes. But I would tell you, what was that?
So the clustered index program, maybe?
1 minute. So, clustered index, doing anything with that is not going to get you where you need to be. I'll show you, we'll do a test rebuild, because I've actually got that here, right over here. So, let's rebuild that. It's going to run for a little bit, and it's going to throw out an error. It couldn't rebuild that table. It's because this is a system page. Now, I could run repair allow data loss, right? But we have no guarantee it's not going to get rid of data. However, if I try to run a repair rebuild, again, it's going to hit errors. In this specific scenario, we need to restore from backup. Right? However, call Microsoft. Because let me show you something. We know that there's exactly 5,000 rows in the table. Let's run repair allow data loss. We get a whole bunch of information back. We can see that it found errors, right? And where is my mouse? And there it is. And it fixed them. The error has been repaired. Yeah. So, if I go back and I do a query out of that table, let's see what it got rid of. If we look down here, we'll see that we got lucky. Now, I've done this exact corruption before. Sometimes you lose data, sometimes you don't. All right, we are at time. I hope you now understand backups better and why you need them.
But if this would be a very large table, you would probably not know if you lost data right away. So maybe you should then take a restore anyway and try to...
I would tell you to do a restore from the get-go. I wouldn't run repair allow data loss. I just wanted to show an example of that command. Do we have any other questions at the end? Yes, as soon as I am given a place to upload it, I absolutely will.
So are you saying that if the corruption is in the system area, might be safer than if it is in the data pages?
Potentially, but it's a case-by-case basis. It could be worse, to be honest. If certain pages go corrupt, your whole database is toast. So,
I mean, could I just like select it from this table while it was corrupted? Would this select return with the results or not? Can I just copy the table outside?
so it would likely hit an error the second it tried to find out the next extent allocated to that object. Yes, he's raising time, so let's be real quick. If it's the master database, just restore. That doesn't change that often. And don't mess with that. Thank you.